So looking at our last topic in all of Math 10C, we're going to look at solving triangles. So we're going to use all three of our trig ratios, all of the things we know about triangle properties, to be able to solve for all unknown sides and all unknown angles, right? Solving a triangle means tell me everything about this triangle, and tell me all three angles, all three sides. We're going to use everything we know about triangles to this point, any of the trig ratios, so it might be some combination of sine and cosine and tangent, right? It might be using 1, 2, or all three. We can use the Pythagorean Theorem, right? As soon as we have two side lengths, we're free to use, right? A squared plus b squared equals c squared. And if we have two of the angles, we can use that triangle sum, right? All angles total to 180 degrees. Right? So we can use all three of these things to find everything about a specific triangle. So we have some triangles here. Let's solve these triangles. Starting off the same way as always, we have a couple of pieces of information. Right? We're going to find everything else about these triangles. So in this first triangle, again, starting with the information I'm given, because I'm given this 35-degree angle, let's use that as our reference angle. Right? Let's use that to figure out, labeling my sides, which one is going to be the hypotenuse, well, up here, length AC, right, across from that right angle. From the 35-degree angle, that means that 15-centimeter side is opposite, because it's on the far side. And length BC, right, the length right beside my angle is going to be my adjacent. So we can use that to our advantage. Now we have a bunch of options. We can decide whichever side we want to find first. Because we have access to all three trig ratios, right, and I know the opposite side. Again, I have SOHCAHTOA. I'll write that up at the top here. Because I have the opposite side, right, I could use sine or I could use tangent. It just depends on whatever side I want to find first. Let's use tangent. We just spent some time going over sine and cosine, so just for fun, let's find tangent. Let's use tangent to find the adjacent side. So, writing out my blank slate formula first, tangent of theta is, and we go back to our acronym, it's opposite on top, adjacent on the bottom. Plug in what we know. I know that 35-degree angle. My opposite length is 15. My adjacent length is my unknown, let's call that x. Right, when we have that unknown on the bottom, we're going to want to cross multiply and divide. So I cross multiply that x up to the left side. X times tangent 35 equals 15. Now to get x by itself, now I do the divide portion. I divide by tangent 35, which remember that's just going to be the decimal form. That's the ratio of how the opposite and adjacent sides are related for an angle of 35 degrees. X equals, and this is where I pull out my calculator, making sure it's in degree mode, right? You see that degree somewhere on your calculator. And I'm going to do 15 as my numerator. And tangent 35, not inverse, right? I wasn't trying to isolate the angle. I know the angle. And I get a 21.4 as my length. So x is 21.4 centimeters. So that's part of my triangle now. I can write that in if I want. There's two more things I need to know, right? I need to know angle A, and I also need to know side length AC, right? From A to C, my hypotenuse essentially. And again, I could use all kinds of trigonometry to find these. I can use some of those trigonometric ratios, right? I could say, all right, now I have two side lengths. And let's use the tangent ratio again from angle A. Or I can say, hey, I know two of those angles now. Right? I know that angle A and B and C are going to total to 180 degrees. And I know angle C, and I know angle B because that's my right angle. So angle A plus that 90 degrees for B plus that 35 degrees for C, that has to total to 180 because of those triangle properties. right? So it's kind of that idea that I'm taking 180 degrees, I've lost 90 for angle B, and I've lost 35 for angle C. That's telling me that I have 55 degrees left over for angle A. And so we found angle A, and it's 55 degrees. So now I know 2 of my 3 sides, I know all 3 of my angles. The only thing left is to find the length of the hypotenuse, right? The length of line segment AC. Again, tons of ways we can do this. I could do sine, right? I could do opposite over hypotenuse using that angle C. I could do cosine if I used my new angle A, right? I could use tangent if I used the 21.4 centimeters I already found. I could use any possible option, including, because I have 2 side lengths now, I can use the Pythagorean Theorem, right? A squared plus b squared equals c squared, or in terms of what we're looking at here, technically it's O squared plus a squared equals my hypotenuse squared. And I know my 2 side lengths. We can find our hypotenuse that way. All right, so it's whatever you prefer once we get to this point. If you'd rather use the trig ratios, awesome. I'm going to plug in what I know. I know my opposite length is 15. I know my adjacent length is 21.4, and ideally we're going to keep as many decimals from our calculator as we can. And that's going to be our hypotenuse squared. So 15 squared is going to give us 225. 21.4 squared. So I'm going to, if at all possible, go back and take more of these decimals, 21.4222. Let's take a few of them and square that, right? Keep as much precision as we can. So 458.9. That's going to be my hypotenuse squared. All right, so I'm going to add these 2 together. I'm just going to, from this answer, go plus that 225. 683.9. And remember, this is h squared, right? Critically think, say, does it make sense for my sides to be 15, 21, and 683? Probably not, right? Your hypotenuse is not way, way, way bigger. And I need to just find h, so I'm going to square root both sides. So I'm going to go to my question, I'm going to square root that answer, again, taking as many decimals as I can. Try not to round until your final answer. And it looks like we get a 26.2. So h, 26.2. Or again, we can call that length AC. And again, all of our other sides were in centimeters, so this one is going to be in centimeters. So we successfully solved this triangle, 26.2. Right, again, does it make sense? Yes, all of our numbers are fairly similar. Is our hypotenuse the longest side? Yeah, definitely. So does this make sense? Definitely. This looks like a reasonable answer, right? Check your answers for reasonableness. Does it make sense? Do the numbers seem like they work together? Is something way bigger than something else? Those are some things to check for in your final answer. So let's do one more. Let's solve triangle B. All right, so let's look at triangle B. I've zoomed in, made a little bit more room here. So again, we have 2 things that we know. We know 2 side lengths. We know 1 angle. So we're missing angle J. All right, let's just keep taking inventory of what we want to find. I need to know length JD. All right, this hypotenuse length along the side. I need to know angle J, and I want to know angle D. All right, those are the 3 things I'm missing. Because again, I'm given 2 side lengths, and I'm always given that 1 angle, that right angle. So let's go through, let's find each of these things. Again, where you start is completely up to you. We could start by finding any one of these 3 things. Maybe again, it makes sense. Hey, I have 2 side lengths. Let's just pretend we're back in 8th grade, and I know 2 sides of a triangle. Let's find that 3rd side. So let's go for length JD. Same idea, a squared plus b squared equals c squared. Again, we're looking for the hypotenuse, so our c is going to be our unknown. 6 squared plus 10 squared equals, and we'll call it whatever. We can call it side length x if we want. We could call it JD. 6 squared we get. These ones have some nice numbers, right? Because we didn't have to solve for any of these. They were given to us. 36 plus 100 is x squared. And so that length is actually going to be the square root of 136. We'll figure out what that is. Oops. Square root of 136. 11.66. So that's length JD. 11 point, let's say 6. And not centimeters, our units look like they're inches this time. So one thing off our list, one thing solved already. So let's find our next portion. Let's find angle J. Alright, so again, finding an angle, this is going to involve me labeling my sides. As soon as I need to use one of those trig ratios, I want to choose a reference angle, right, either J or D in this case, and label my sides with respect to that angle, right? So my hypotenuse, which we just found, my opposite is going to be this side of length 10, right? Again, if I was looking at angle D, my opposite would be a different side. My adjacent of length 6 up at the top there. So, going to find angle J, again, I have a bunch of options. I could use tangent again. That would be using the numbers that were given to us. That's probably your best bet, right? But when you can use numbers provided in the question, I would recommend that, just in case you made any mistakes or any rounding errors or anything in your original calculation. But we'll use length JD. We'll use that 11.6 length just so we can try out some other trig functions. So I'm going to use, let's see, let's go with cosine. Right, let's use my adjacent side and the hypotenuse that we just found so that we can find that angle. So, angle J. Starting with my blank slate, right, cosine theta, adjacent on top, hypotenuse on the bottom, right, adjacent first, then hypotenuse. I'm going to plug in the things that I know. I don't know my angle, right, that's my unknown here. But I do know the ratio. I know that A, our adjacent length, is 6 in comparison to our hypotenuse of 11.66. Remember, when I'm solving for an angle, that's where I need to take the inverse cosine. Right? I need to get theta by itself. I need to unlock it, right? Get it out of that cosine. And the opposite of that cosine is the inverse cosine. But I'm going to have to do that to both sides. Right, so I do it to the left side, it uncosines that angle, I can find that angle, isolate it. But then when I do it on the right side, on my calculator, right, I'm going to find that inverse cosine function on whatever calculator you're using. I'm going to put 6 on the top, and then I'm going to take, right, if that answer is still there, I'm going to take that answer function so that it's keeping all of those decimals for me. And so that tells me that angle is 59.03. All right, let's call that 59 degrees. Last one, so angle J, 59 degrees. So let's do that in blue. Let's keep our color code consistent, very important. 59 degrees. And the last one, angle D. So again, right, I now have 2 of my 3 angles. Right, I was given angle E of 90 degrees. I found angle J. Right, I could do that angle rule, right? Add up to 180 to find angle D. But for the fun of it, just because we'll try using all of our ratios, let's find angle D using sine. We haven't used that one yet. So again, labeling my sides based off of angle D. Right, so that's going to have an opposite of 6, an adjacent of 10. And a hypotenuse of that 11.6, right, that one doesn't change. But my opposite and adjacent do have to flip because I'm looking from a different corner. Here I said I wanted to use sine, so I'm going to use opposite and hypotenuse. Let's get that one set up down here at the bottom. So angle D, And I want to use the sine ratio, just because I can. Alright, opposite over hypotenuse. So, don't know my angle, right? That's what I'm looking for. I can call it d, I can call it theta. My opposite was 6. My adjacent was 11.66, right? Notice this looks exactly the same. The ratio is the same as my cosine, but it's going to give me a different angle because it's comparing two different sides, right? This is now the opposite compared to the hypotenuse versus the adjacent compared to the hypotenuse. So again, I take that inverse sine to undo that sine on the left, but it's going to show up on the right now as well. So going back to our calculator, inverse sine of 6 divided by, and that same answer, that 11.6619, I'm going to try and copy at least 3 or 4 decimal places here since I can't get the full answer. And when I hit answer, right, notice that the sine and the cosine of the exact same ratio, right, it's still 6 over 11.6. Right, the cosine and the sine ratio give us different angles because they're comparing two different side lengths. So here, that angle D is 30.9, so let's call that 31 degrees. Right, as you can see, 31 plus 59 gets us to that 90, right, with the other 90 totaling us to 180. So we get 31 degrees, right? So many different ways we can solve a triangle now that we have all of these tools at our disposal. Just up to you which ones you're more comfortable with, right? Do you struggle with Pythagoras and make little mistakes? Then don't use it, right? Use a trig ratio. If you would rather total up the angles, right, so you're not making as many little mistakes in the trig ratios, awesome. Just make sure you're finding all of those sides and you're trying to keep it. If you're using numbers you've already calculated, try to keep as many decimal places as you can. And as I'm looking at this, I'm realizing this should be 11.7. Poor rounding skills on my part, my apologies. And so that's going to take us to the end of our trigonometry unit and the end of Math 10C. If you have any questions on this stuff, please let me know. There's some practice up on D2L, and there's your quiz that you'll be completing. Send me an email. Hit that subscribe button to look at some Math 20 content next year. And I will see you guys later.